Hi, calculus student. This is a chapter. This video is for chapter 4.1, part 4, more work problems. So we'll do two work problems, two types of work problem. One is for ladder sliding down the wall, and the other is for shadow problem. So they are all very popular related way question. The first one is about a ladder 25 feet long is leaning against the wall of the house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second, maybe sliding away due to various reasons. But this is what is happening. We want to know how fast is the top of the ladder moving down. So it seems like from a common sense point of view, you would think that, oh, maybe it should be just still 2 feet per second because this ladder is fixed, right? But it turns out that it is not. So what happens is we represent this being the wall, and then we'll draw a ladder that leans against it. This is fixed length 25 feet. And we say this because when it is sliding away from the wall, so this X is changing, this Y, which is the top of the ladder to the ground, is also changing. Okay, so what is relating them? This is the wall and the ground. So the things that relate them would be X squared plus Y squared equal to 25, right? And what are they asking? How fast is the top of the ladder moving down the wall? So we need dy dt. Okay, how fast? How fast? And we know dx dt is equal to 2 when x is 7. So we know these sets that we can use if we have dx dt and dy dt's formula. So what we do is we'll do dt on both sides. X squared plus y squared equal to d dt for 25. So this is a constant. Of course, this is 0. And then we will do dt for both of them. We have to do change of variable. Dx, 2x dx dt plus do dy, which is 2y, but we're supposed to do dt, so we just attach dy dt at the end. So we related both of them, and we can actually move around and say, well, x dx dt is actually equal to negative y dy dt. What do we not? We need dy dt, so maybe we'll just say dy dt is negative x over y dx dt. So do we have everything? We have dx dt, we have x, but we don't have y, so we have to calculate y first. When we know x is equal to 7, can we calculate y? So this is the case when we actually can plug in x is equal to 7 now. It's 27, and what is y? So y is equal to, by Pythagorean theorem, because it's the wall vertically, so be 25 square minus 7 square. If you put in the calculator, it's actually 24. So plug in here, so we would say dy dt is going down, is negative. X is 7, y is 24, and dx dt is 2. So that will be negative 7 over 12. Is it feet? Feet per second. It's moving down not as quickly as the ladder is pulling away. Okay. The second question is about shadows. It's also a very, very typical question. When someone walks away from a lamppost, so the shadow would be here, right? So because the person's body blocked the light, so there will be a shadow. So let's look at this. A man 6 feet tall walks at a rate of 5 feet per second. So let's look at this. This person is walking away. So we can say this is X. From a light that's 15 feet above the ground now. This is fixed. It's 15. It's not changing. Okay, so we can write 15 now here. When he is 10 feet from the base of the light, at what rate is the tip of the shadow moving? So the tips of the shadow is here. It's, of course, is changing when x is changing. So we would just say it is y, because it's talking about the tips of the shadow moving, of course, relative to the lamppost, right? So then we have also 6 feet of the man, which is constant. So now, how does x and y related? Because we have what? We have the man walk away as the x dt is 5, right? And we need dy dt. So how do they relate? It turns out that they are related by a similar triangle again. So the big triangle is 15 and y. The small one is 6 and what is this? Y minus x. So y minus x. So we can just use 15 over 6 is equal to y over y minus x to relate them. 15 of y minus x is equal to 6y. So then we would say 15y minus 15x equal to 6y. Rearrange them, so 15x is on this side. 15 minus 6 is 9y. So that means we can actually relate x and y now. So, or we can say y is 15 of 5 over 3x. And if we do dt on both sides, we say dy dt is 5 over 3 of dx dt. Right? Minus 6 is 9. So if I want to know how fast the tip is moving, it will be 5 over 3 times. What is dx dt? Is 5. It's 25 over 3. Is it feet? Yeah, feet per second. So you do not need to plug in this 10 feet from the base. So at any point in time, it would just be 5/3 of whatever the man's walking. The second is when he's 10 feet from the base of the light, at what rate is the length of the shadow changing? So we're looking at another measurement. So it's still 15. We still have the man is 6 feet here. This is still x. And we still have dx dt is 5. But the length of the shadow is here, so we say this is y. Okay. Now all of a sudden we have two triangles that are similar. One is 15 and x plus y. In this particular case, y is something else. It's the length of the shadow. The previous one, y is how far away the shadow is from the lamppost. And then we have a 6 and y. So again, use similar triangle. 15 over 6 is equal to x plus y over y. So in this case, we have 15y equal to 6x. Use the big cross things. 6x plus 6y. And then again, I move the y over. I have 9y equal to 6x. The other side, we have 9y equal to 15x, but this is 9y equal to 6x. So my dy dt would equal to 2 over 3 dx dt. Right, if I do dt on both sides. Right, so then dy dt, how much the length of the shadowing is changing would be, so dy dt would equal to, because the length of the shadow is y, so we need dy dt. I should write it down earlier. Dy dt. So dy dt is 2/3 times what dx dt was. It was 5 from before. So it's 10 over 3 feet per second. So it's changing, but every second is 10 over 3 feet. Okay, so that's the shadow problem.